Electric charge is a basic property of matter that causes objects to attract or repel each other. In the previous lab, we observed how charged objects interact, but we were not able to measure those interactions. In this lab, we will make predictions, test them, and record observations to better understand how objects become charged and how charges transfer between objects. Objects can become charged in different ways, such as by friction, like rubbing materials together, conduction, and induction. When a charged object is brought near a neutral conductive object, the charges inside the neutral object rearrange temporarily. The process is called polarization and can cause attraction even if the object remains overall neutral. If the objects charge can transfer, which may cause them to have the same type of energy and the same type of charge. This will cause them to repel each other afterward. In this experiment, we will use an electrometer to determine the type of charge on rods rubbed with different cloths. We will also observe how charged rods interact with neutral conductive objects, included grounded aluminum foil and an isolated pith ball. Finally, we will explore how to charge a sphere positively by induction. The goal of this lab is to better understand how electric charge works and how charged objects interact. The main instrument for this session was a Faraday ice pail. Faraday ice pail is a conductive metal container made out of aluminum. On the bottom, it has a plastic stand to help it insulate from the ground. We also used the electrometer. The electrometer is a high-performance electronic measuring equipment. It consists of a metal input that helps connect black and red clips onto the Faraday ice pail. In order to read the currents, it displays a needle that physically deflects to the right or to the left side. This session also required the planes. The planes are conductive discs attached to an insulating plastic handle. It is used to sample electric charges from objects. Pith balls are lightweight spheres attached to a rod that helps measure electrostatic forces. Insulating and conducting materials were also used for this session. Acrylic, glass, and PVC rods were used as insulating objects that could be charged through friction using silk, fur, and wool.
We first began by setting up the electrometer by connecting the red banana plug to the ice pail and the black banana plug to the shield. We also connected the signal input cables and attached the ground cable to the bottom of the table. Then we pressed the on button to turn it on and made sure the reading was at 0. We also made sure that the voltage scale was set to 3. Next, we rubbed each rod, the acrylic, glass, and PVC, with each fabric, fur, silk, and wool. After rubbing, we place the rod near the electrometer probe and observe the reading. We record whether the electrometer showed a positive, negative, or neutral charge for each rod and fabric combination, ensuring to discharge the probe between each reading. In this clip, we observe the acrylic rod being rubbed with each fabric, our fur, silk, and wool. While in this clip, we are observing our glass rod being rubbed with each of the fabrics, fur, silk, and wool. In this clip, we are observing the PVC rod being rubbed with each fabric, fur, silk, and wool, and observing whether the electrometer shows a positive, negative, or neutral charge for the fabrics.
A, we charged the acrylic with the rod and we predicted that the aluminum foil will be attracted.
For part A, we had our charged acrylic rod and our dangling aluminum foil. We brought our charged rod close to the aluminum foil without touching it and observed our findings.
Rod, and then we charged it and we predicted that it was going to repel.
For part B of this lab, we first began by charging our acrylic rod with our fur fabric and touching our aluminum foil. We then separated them and touched them again and observed our findings.
Isolated system, and we think it's going to be attracted to our charged rod. This is the negative one, and we think it's going to be repelled by our rod. And then this is our negative system, and we think it's going to be attracted to our rod.
We have our isolated, conductive, and neutral pith balls. We brought our charged rod close, separated them, and touched them back to each balls, and observed our findings. For E, we had our positively charged rod brought near one of our pith balls. We then allowed the electrons to transfer over to the pith balls. And then separating our pith balls, we observed the new electric charge each had.
Here we have our collected data after charging each rod with a different material. When charged with fur, the acrylic rod was found to be positively charged and negatively charged when charged with both silk and wool. The glass rod was observed to have negative charge when charged with fur and wool, but had a neutral charge when charged with silk. Finally, the PVC rod was observed to have a negative charge when charged with fur and wool, but, like the glass rod, had a neutral charge when charged with silk. Data Part A. After bringing the fur-charged acrylic rod close to the aluminum foil, our group predicted that the aluminum foil would be attracted to the rod. When testing this prediction, our group found that the aluminum foil was indeed attracted to the fur-charged acrylic rod. Data Part B. After touching and separating the charged acrylic rod, our group predicted that the aluminum foil would be repelled by the rod. After conducting this portion of the experiment, our group observed that the aluminum foil was still attracted to the rod despite being previously separated. Our group predicted that when we brought the charged acrylic rod and pith ball together without touching, the pith ball foil would be attracted to the rod. After conducting the experiment, our group found that the pith ball was attracted to the fur-charged acrylic rod. Data Part D. After touching and separating the fur-charged acrylic rod from the pith ball, our group predicted that the pith ball would still be attracted to the rod. After conducting this portion of the experiment, our group observed that the pith ball was still attracted to the charged rod after the rod was touched, removed, and moved back to the pith ball. Conclusion Part A. Our group correctly predicted that the aluminum foil would be attracted to the fur-charged acrylic rod. Our group made this prediction after observing that the fur-charged acrylic rod had the greatest positive charge when measured in the electrometer. Because the aluminum foil was neutral, we observed how the positively charged rod induced polarization when placed near the foil. The negative charges of the foil were drawn to the positive charge of the rod. Conclusion Part B. After touching the rod against the foil, our group predicted that the foil would be repelled by the positively charged wand. We predicted that the touching the rod and foil together would result in a change of charge due to a transfer of electrons. However, we found that after touching, the foil was still attracted to the positively charged rod. We suspect that the neutral foil was still attracted to the rod because the positively charged rod attracted the foil's electrons, creating a dipole due to conduction. Conclusion Part C. Our group correctly predicted that the pith ball would be attracted to the positively charged acrylic rod. We made our prediction because, as previously observed in Part A, the neutral aluminum foil was attracted to the positively charged rod. Since the pith ball was neutral, we predicted the same outcome would happen due to the positive rod attracting the foil's electrons. This phenomena can be described by induction. Conclusion Part D. Our group correctly predicted that the pith ball would be attracted to the rod even after being separated. Our group predicted this due to the outcome of Part B, where we observed how despite separating the foil and rod, the foil was still attracted to the rod due to its positive charge and a dipole formation between the two objects following conduction. Part E Conclusion. To reach the goal of Part E, our group began by charging the acrylic rod and making it positive. Using the positively charged rod, our group placed it near the neutral spheres to create a dipole. When measuring their charge in the electrometer, we were able to see how the spheres now had different charges due to the rod attracting the electrons and pulling them to one side via induction.